Hey, welcome back. Section 8.7, please do not get confused because we're going to jump around in Chapter 8 a little bit. It makes more sense this way. 8.7 is on scheduling with independent tasks. Remember, we talked about independent tasks. These just have no precedent relations, so there's no requirements. Any one of these tasks can be started at any time in any order that you want to do them in. Okay? So, what does the actual project diagram of independent tasks look like? Example, draw a project diagram for tasks A, B, C, and D that takes 5, 2, 3, and 7 minutes to complete respectively. Okay, so all this means when your tasks are independent is, yes, you still have a start and an end point. So you've got a start and an end. All 4 of these tasks can be done right off the start. Okay? So this is A, B, C, and D. Any one of these tasks can be done directly from the starting point. Okay? And then all of the tasks will lead to the end. Nothing has to be done before anything else. Okay. Scheduling independent tasks. How do I schedule them in the shortest amount of time? We want to find the fastest way to complete the above tasks for the project with the given number of processors. Okay, so the way we do this is think about the total amount of time it takes to complete these tasks. So, task A, B, C, and D. Said it took 5 minutes, 2 minutes, 3 minutes, and 7 minutes to complete. Okay, so that's a total of 17 minutes. Okay. If I have 2 processors or 2 people working on them, I've got 17 minutes split between 2. That gives me 8.5. But remember, we can't split any time. So it's going to take 9 minutes for 2 people to complete all 4 of these tasks. Well, what tasks can I group together that gives me 9 minutes or less? Let's see. Task D takes 7 minutes. And task B takes 2 minutes. So let's put D, 7 minutes. So that takes me out to here. Sorry, that not straight line is going to bug me. D takes 7 minutes. And B takes 2 minutes. So that takes me out to 9. And then I can group together A, which takes 5 minutes, and C, which takes 3 minutes. So that's 8. Okay. But remember, this has to take a total of 9 minutes. So, what's going to happen for this last minute here that processor 2 is not doing anything? They have what we call idle time. It's basically where they wait around and wait for somebody to finish so the project can be done. Okay. Three processors. Okay, our total amount of time has not changed. So we're still looking at 17 minutes. This time we're splitting it between 3 people. It's 5.6, no, 5.7. So approximately 6 minutes it should take. Okay. Remember, our task took 5 minutes. A takes 5 minutes. B takes 2 minutes. C takes 3 minutes. And D takes 7 minutes. So, what's our problem between our time and how long it takes one of our tasks to be completed? This can never be less than our largest amount of time. So this actually is going to have to take 7 minutes. So one of these processors can work on D, which takes a whole whopping 7 minutes. Okay, I don't want anybody to be lazy, so I'm going to group B, which takes 2 minutes, and C, which takes 3 minutes together. And then I'm going to let processor 3 work on A, which takes 5 minutes. Okay. So again, we've got that idle time. 4 minutes idle. How can we calculate that idle time without actually drawing out what's happening here? Okay, think about it. We came up with 7 minutes. Each person has to work 7 minutes. So if I've got 3 processors, 7 times 3 is 21. In all reality, it should only take 17 minutes to do all 4 of these tasks. So if I subtract 17, that gives us 4 idle. Okay. All right, 4 processors. So we've got 17 minutes and we're dividing it between 4 processors. Okay, so that's 4.25. Again, it cannot be any lower than our largest task. So these, it's also going to take 7 minutes. So let's go ahead and actually calculate the idle time before we actually schedule these this time. So I've got 7 minutes and 4 processors. That's 28 total minutes. Minus 17 that it should take. So we should have 11 idle at the end. Let's go ahead and schedule these and see what we got. Okay, because we have 4 tasks and 4 processors, each processor can work on a task. So processor 1 can work on A, processor 2 can work on B, processor 3 can work on C, processor 4 can work on D. Okay, let's see how much idle time we've got here. So everybody's going 7 minutes. So that's 1, 2, 3, 4 idle minutes. 1, 2, 3, 4, 5 idle minutes. 1, 2, 2. So that's 9, 10, 11. 11 idle. Okay. For independent tasks, E 4 minutes, F 5 minutes, G 2 minutes, H 6 minutes, I 7 minutes. Find the fastest way to schedule. Okay, we're doing 2 and 3 processors. So the first thing we have to find out is total time. Whoops. Keep doing that. So we want total time. So let's see, that's 7, 13, 15, 20, 24. Okay, so 24 split between 2, we're looking at 12 minutes. Okay, none of my tasks take more than 12 minutes, so we should be good at 12 minutes. Let's see if we should have any idle time here. So I've got 12 minutes and 2 processors working. That's a total of 24 minus 24. I should have 0 idle time. Okay. So let's see, what can I put together that's going to give me 12? 7 and 5 go together to give me 12. So we're going to work on I and F. H is 6 minutes. G is 2 minutes, so that takes us to 8. And E is 4 minutes, that takes us to 12. With no idle time. 3 processors. 24 divided by 3, that's 8. Technically, we should have no idle time here either. Let's see what happens, right? Because we've got 8 times 3, oops, 3, which is 24 minus 24. It should be 0 idle. Let's see what happens. What can I pair together to get 8? Let's see. H and G. H takes me to 6, G takes me to 2. So we've done H and G. What's our problem here, though? The tasks aren't split enough to get us 8. So processor 2 is going to have to work on I up to 7 minutes, and processor 3 is going to have to work on E and F. So this is actually going to be a 9-minute instead of 8. And we are going to have some idle time here. So depending on the length of the tasks, you may end up with idle time even if you don't want it. Okay. Example 3. Let's see. Oops. Total time for these tasks are 1, 2, 3, 4, 8, 16 it looks like. 16 split by 2, we're looking at 8. Let's see if we can schedule this in 8. D and F can go together. D takes 3, F takes 5. So then everything else. A takes 1, B takes 1, C takes 2, E takes 4. 3 processors, 16 divided by 3, that's That's 5 point something, so 6. Okay, so 6 minutes, we can put E and C together. E and C. F goes 5 minutes. A goes 1 minute. And then D goes 3 minutes. B goes 1 minute. And we've got 2 minutes of overtime, or idle time. Okay, again, we can check. It should be 6 times 3 processors, that's 18, minus the total amount of time, that's 2 hours or 2 minutes idle. Okay. And finally, between 4 processors, that's 16 divided by 4, that's 4. It can't be any shorter than our longest. Okay, so we're looking at 5 then. So one of them is going to work on our longest task. We don't want to go any more than 5. So let's do E here, 4 minutes. We'll put D and A together, that's 4 minutes. And C and A together, or C and B together. C takes 2 minutes, B takes 1. So 1, 2, 3, 4 idle. So let's see, 5. What did I just do? I don't know what I just did. 5 times 4, that's 20, minus 16, we got 4 idle. Last example, and then we're going to do some practice problems. Example 4, 3 friends are cooking a 9-course luncheon with each course listed with processing time in minutes. Find the fastest way to schedule all tasks with 3 processors. So for those of you that are taking ProStart or anything. So the first thing we need to do is figure out the total amount of time we have here. So if we add all these up, that's 100, oops. That's 100, that's 200, 300, 400, 540. So total 540. Okay, we're going to try to split this between 3 processors. So divide that by 3, that's 180. Let's see what I can group together in 180 minutes. So I can schedule C and H together, that's 180 minutes. So task C takes 100 minutes, task H takes 80 minutes. E, F, D, and I. E takes 80, F takes 20, D takes 70, and I takes 10. And then the last ones. A is 70. B is 90. So that takes me to 160. And G is 20. Takes me to 180. Is 180 minutes optimal time and why? Think about that question. Think about idle time. This is yes. There's no idle time here. Okay, exploration. If you know all of the processing times and the number of processors, can you calculate a minimum number for the finishing time? Yes, we do this every time. Okay. Finishing time. Has to be greater than or equal to total time divided by number of processors. Remember, if it comes out to be a decimal, you have to round it up. If it's less than your biggest task, you've got to go by the biggest task time. And sometimes it's not always accurate either because you don't have the task split enough that you can even it out. If you know all of the processing times, can you make statement of the minimum time for the finish regardless of the number of processors you might assign? This is what we just talked about. Remember, your finishing time has to be greater than or equal to your largest individual processing time. Okay. If one of the tasks takes 7 minutes, but when you split it up, it only comes out to be 6 minutes, well, you can't split up that time, so it's got to take at least 7 minutes. Okay. So, just a little recap of what we just did, making optimal schedules. All tasks are ready from the start because we're talking about independent tasks, so nothing has to be done before something else. Processors will never idle until the absolute end when there's no task left to complete. 3, we calculate the total processing time divided by the processors. To get your finish time, you take your total processing time and divide it by the number of processors. And finally, use the given processing times to make each processor get as close as possible to the calculating finish time so we can schedule them. So let's practice everything we just did. Find the optimal schedule for the given processors and tasks. So again, we've got to find total time. Always, always first step, total time. $270 here. Divided by 3 processors, we're looking at 90. So processor 1, processor 2, processor 3. What can I group together to give me 90 minutes? E and G. F, D, and B. And A and C. Two processors and tasks. Again, we need total time. $280 divided by 2. Our goal here is 140 minutes. Processor 1, processor 2. It looks like A, B, C, and G can go together. And D, E, and F. Okay, let's do 4 processors and tasks. So total 360 divided by 4, it's 90. B and C. A can be done all by itself. I and F. 50, 60, 70, 80, 90. D, E, G, H. Number 4 is slightly difficult. 3 processors and 18 independent tasks with processing times given by 1, 2, 3, 4, 5. So we're counting up all the numbers between 1 and 18. Each processor each task. Task 1 is 1 minute, task 2 is 2 minutes, 3 is 3 minutes, so on and so forth. So total time here is 1 plus 2 plus 3 plus 4 plus 5, the whole way up to 18. So you should have a total of 171. And we're dividing this by 3. It's 57. $18, 13, 12, 7, 6, and 1 can go together. 17, 14, 11, 8, 5, and 2. 16, 15, 10, 9, 4, and 3. Okay. Your homework tonight is going to be worksheet 8.7. Okay. This one will be on paper. And I will see you back here tomorrow.